When you delete a file, your computer does not actually erase it. So, what actually happens when you hit delete, and why is undoing it so easy? Well, to start things off, your hard drive is one large space made up of millions of small storage blocks. When you save a file, the operating system writes the data into some of those blocks and creates an entry in something called the file table. The file table is an index. It records the file name and the block numbers where the data lives. When you open a file, the system reads the index, finds the block numbers, and retrieves the data. That index is the only connection between the file name you see on screen and the actual data on the drive. So when you hit delete, what do you think happens to it? What actually occurs is that your operating system removes the entry from the file table. The blocks containing your actual data are untouched. The system marks them as available for future use, but until something writes into those exact blocks, the original data sits there completely intact. It is technically still findable and readable on the drive, but only if you bypass the normal way computers access files. This is essentially how file recovery software works. It basically ignores the file table entirely, scans the raw blocks directly, and looks for data that still resembles a photo, a document, or a video. The file was never gone. What actually happened was that the index just stopped pointing to it. Every year, millions of old computers and hard drives get sold or donated after their owners delete everything and perform a factory reset, assuming that's enough. But neither of these steps actually erases anything. Deleting files simply removes their file table entries, like we covered. And a factory reset does roughly the same thing across the entire drive, clearing the file table, but not the data itself. This is also why formal organizations follow strict data destruction policies for decommissioned hardware. On these devices, a reformat alone, from a recovery standpoint, is basically pointless. Everything described so far, however, is on traditional hard drives. On the other hand, solid-state drives, or SSDs, which are what most modern devices function on, run differently, and in a way that allows them to get closer to real deletion. SSDs have a feature called trim. Shortly after a file is deleted, trim tells the drive's controller that those blocks are no longer needed, and unlike a regular hard drive, the controller can go ahead and physically erase them at the hardware level. Because of this, recovering deleted data from a modern SSD is significantly harder than from a hard drive, and in many cases the data is actually gone within a short time after deletion. The only issue is that trim isn't an instant or guaranteed process. There's often a delay before the actual erase happens. Whether trim works at all depends on the operating system, the drive, and how it's connected. Some setups don't even pass trim commands through, and due to how SSDs manage their memory internally, traces of data can sometimes still exist in places trim doesn't reach. At this point, the question that has been lingering is if deleting won't actually delete, what will? The answer is a technique called overwriting. This is when specialized software writes new data directly into every block that contains the original file, multiple times in some cases. Once those blocks contain new data, the original is gone. Tools like DBAN handle this for full drives being decommissioned. This, however, only really applies to traditional hard drives. For SSDs, on the other hand, direct overwriting is unreliable because of how the drive manages wear internally. Instead, the practical approach is full disk encryption. This is because if the entire drive is encrypted and the encryption key gets destroyed, every block on the drive becomes unreadable regardless of what data is still sitting there. For any device that had encryption enabled by default from the start, which includes most modern phones and computers, just deleting is actually reasonably secure. Although the data is still technically recoverable, since the data was never stored in readable form to begin with, destroying the key instantly makes everything unreadable, regardless of what physically remains on the storage chips. The same recovery software that can reconstruct a deleted file on an unencrypted drive will on an encrypted device only ever pull back unreadable ciphertext, as there's no file structure left to find. To summarize everything, delete never actually fully deletes, not on a hard drive, not even on an SSD. The file table entry disappears, but the data just sits there unless overwritten by something else. What does change, though, is what is sitting in those blocks. On a drive without encryption, usually an older hard drive, a USB stick, an SD card, and plenty of computers, that data is still sitting there in its original, readable form after being deleted. The recovery techniques we covered work on it exactly as described, and the result is a usable file. In this scenario, the phrase delete doesn't delete plays out in the most literal way. On the other hand, on a device that's had encryption on from the start, including most modern phones, computers, and modern devices that run on SSDs, that same data was never stored in readable form to begin with. The recovery process still works the same way. It still finds the leftover data, still pulls it off the disk, but instead, what it pulls back is data that is structureless and useless without the key. Although the mechanism never changes depending on your device, and deleting still doesn't really delete, what does change is whether the data being still there means it is still readable. Before you assume that deleting a file was enough to ensure that it cannot be accessed, find out if your device was encrypted from the start. Because if it wasn't, the file is likely still fully recoverable in readable form,